Welcome! Have you ever seen a world map like this? This projection map is polar centered. There's a pole here. And we can reference points on the map using a distance from the pole and an angle measure. You've already seen that a complex number in rectangular form is z equaling a plus bi. But there's another form of a complex number, the polar form. In this lesson, we'll answer the question, what is the polar form of a complex number? And we'll see how it relates to the rectangular form. Let's get started. You will look at several problems involving finding conjugates, moduli, and arguments of complex numbers, converting between rectangular and polar coordinates, graphing polar coordinates of a complex number, and explaining why different forms of a complex number represent the same number. Here are some important words you'll learn in this lesson. Take a moment to copy them into your eNotes and look their definitions up in your glossary. Argument of a complex number, complex conjugate, modulus of a complex number, polar coordinate system, and polar form. Recall that imaginary number I is equal to the square root of -1. We then define complex numbers as any number of the form a plus bi, where a and b are real numbers. Any complex number a plus bi can also be represented on the complex plane as the coordinate pair a, b, where the horizontal axis is represented by the real numbers and the vertical axis represents the imaginary numbers. This form is also known as complex numbers rectangular form. Take, for instance, the complex number 2 plus 5i. It would look like this, where we move 2 units on the real axis and 5 units up on the imaginary axis. We use the coordinates 2, 5 as the coordinate pair. Now you identify a point in the complex plane.